Aloha and welcome to our video on atmospheric characteristics. In this video we will compare and contrast weather and climate, we'll identify the properties of the atmosphere, and we'll explain why seasonal changes occur. So taking a look at this graph here, what we're showing is the volume of clean dry air. So if we went out and we collected a sample of clean dry air, what the dry means is we take the humidity out of it, and what the clean means is we take the pollutants out of it. What we would end up with naturally is this graph here, and this kind of shows us what our different percentages are of the components that make up our air. Now, as you can notice, most of it is going to be this nitrogen down here, and that's what most of our atmosphere is. The part that's important to us is this oxygen, and that's right up here, and that's what we use to breathe, as well as most organisms do. This one was kind of biologic in nature. Once we had the first photosynthetic organisms going, they converted this carbon dioxide portion here into oxygen. And you can see there's still a little bit of carbon dioxide left. We have a lot more oxygen now. We have some argon, and then we have some other elements out there as well. So this is what our air sample would be like if you were to go out and just collect a sample. Most of it, once again, is going to be nitrogen. There's a large oxygen component, and then there's this carbon dioxide component, which will come into factor later on. Okay, so in the last graph we looked at, we said it was a clean sample. And we know if we were to go out and gather air from Las Vegas, it's not exactly going to be clean. We're going to have some pollutants inside. So these two graphs are going to discuss some of these primary pollutants. If we look at what they are, we'll notice that most of it is going to be carbon monoxide. About half is carbon monoxide. We also have a lot of sulfur oxides, and then we'll also have some nitrogen oxides, and we'll have our particulates, which would be like our dust, things of that nature, and then finally we have some volatile organics up here. Mostly we're going to be concerned about, we're going to be these and these two here. The carbon monoxides, if we go to the other side, you can see that about 46% of our pollutants come from transportation. We also have stationary fuel combustion, which is another 23%. So that would be like our coal burning power plants. We make a lot using the industrial processes that we have. And then we have our miscellaneous, whatever it falls into, and our solid waste disposal. This would be like if we were burning trash. We get about 2.5% of the pollutions come that way. So you can see a correlation between some of these. The carbon monoxide we'll talk about a lot. We'll also talk a little bit about these sulfur oxides. We covered them last semester when we talked about acid rain, and that's where we're getting some of the acids for this to occur. So our pollutants, you can see where they're coming from and then about what they are. And that's what we find in our air if it's not a clean sample. Okay, so in this graph, what we're going to look at is changes in atmospheric pressure with altitude. When we're talking atmospheric pressure, we also sometimes call it air pressure. And we'll talk about that a little bit more in this unit on weather. But air pressure, quite simply, means that it's the pressure of the air that we feel upon us. And we're going to focus primarily on this downward sense because we can look at air pressure as being this column of air above us. And if we look at the graph, we realize that most of the air is going to be at a lower altitude. So what we'll notice is we see this here, we can put in our air molecules, and you can see how it kind of thins out a little bit as we get up higher. So the higher in elevation, there's less air pushing down on you, so you're going to have less pressure upon you, and that's what this graph is kind of showing us. So if we have a significant change in altitude initially, we're going to see a greater change in the pressure, versus as we get higher, that change in pressure is going to be a little bit less and less as we go up. Now in this graph, we're looking at thermal structure of the atmosphere. Basically, how does temperature vary as we travel up through the atmosphere? And we'll notice a bunch of different things. As we go here is 32 degrees Fahrenheit or 0 degrees Celsius, and this is going to be where water freezes. And then we're going to get warmer here and then cooler on this side here. We also see that we have our layers of the atmosphere. So our layer that we live in is the troposphere, and that's the lowest layer. Above that, we have the stratosphere, the mesosphere, and the thermosphere. And we'll talk more about the layers of the atmosphere in the lessons as we go on. One other thing I want to show you is we have this maximum ozone here. So when you hear about the ozone layer, this is what we're talking about. So let's look at the general trends that we have. If we start on the surface, we'll change over here. If we start on the surface of the Earth here, as we travel up, what we notice is it's going to get cooler. So that's why if you go up to Mount Charleston, it's always going to be a little bit cooler here in Las Vegas because as elevation goes up, it gets a little bit cooler. Once we cross into the stratosphere through the tropopause, what we'll notice is that the temperature kind of levels off a little bit, and then we see an increase in temperature up to the top of the stratosphere. And that's primarily because above the ozone layer, we have a lot more cosmic radiation occurring. The ozone layer stops UV light, so we're getting bombarded with more of these particles, and that's going to warm up the atmosphere a certain degree. Once we get into the mesosphere, we'll notice that the cooling trend is going to continue again. And then we get into the thermosphere, and in the thermosphere, we'll see that it's going to extend upwards and our temperature is going to get warmer. And this might lead you to think that space is going to be warm, but in reality, once we exit the atmosphere, it gets really cold in space. This here is just because we're going to have more cosmic radiation occurring. So we can see that by the ozone layer here above that, we notice a warming trend, and then we start to have this cooling again, and then we'll see the warming trend again because we can have more radiation occurring in the upper layer of the thermosphere. Okay, so when we talk about the Earth's axis and its tilt, this is what's going to give us night, day, seasons, things of that nature. So let's take a look at some of the motions and the importance of part of these things. The first motion we're going to talk about is rotation, and the result of rotation is the day. It takes 1 day for the Earth to rotate on its axis, and as it does so, it's going to spin around like this, and it allows the Earth to have periods of heating and cooling. So you'll notice that half of the Earth is going to be heating up, it's going to be daytime, and the other half it's going to be cooling off when it's nighttime. The second motion is revolution, and the net result of revolution is the year. This is our path for the Earth around the sun like this. So that's a revolution. And that's going to change. If we had no tilt in the Earth's axis, we would have the constant weather all the time. It would just be night and day, 12 hours of each all the time. But because we have this tilt, and the tilt of the Earth is what gives us our seasons. It provides a more uneven heating of the Earth's surface, and that's what we'll look at in the next slide here. But I wanted to show you one thing really neat that as we go through. As we look at our Earth is tilted at a 23.5 degrees. So we can see this tilt is right here. So north isn't straight up, it's kind of tilted away from the sun. Now, as you notice, we have a bunch of different lines here. We have our equator here. We have our tropic demarcation here, which is 23.5 degrees. Notice it's the same as our tilt. We'll talk about that a little bit later on. We have our 66.5, which is going to be basically the marcation of the start of the Arctic Circle. And then we have one down here, which is the Antarctic Circle. And we'll talk about the importance of these. Okay, so let's look at this tilt of the Earth, and it's going to give us 4 important dates a year, and these are our solstices and equinoxes. Let's start off with our winter solstice, which happens in December on the 21st or the 22nd. And we'll talk more about these a little bit later on in the course, but I want you to see why this gives us seasons. If you notice, and we draw on our equator, that we can look at any given moment, more of the northern hemisphere is going to be shaded. So it's going to be nighttime longer in the northern hemisphere than it is in the southern hemisphere. This we notice in wintertime. The days are shorter, and because of that, we get less heating. And the reason for this change is because our tilt to the Earth, where northern hemisphere is actually tilted away from the sun. So it's getting less sunlight, so that's why it's going to be cooler. The opposite of the winter solstice is going to be our summer solstice. And notice that that's here in June. And if we draw our line again, notice we have less nighttime than we do daytime. So now the days are longer. We're going to get more heating. So I kind of want you to see that it's the opposite. And notice in the winter solstice, we're faced away from the sun. In the summer solstice, our tilt to the Earth is pointing towards the sun. So we can see those variations. If we look at the summer or the southern hemisphere, in the winter solstice, our winter solstice, notice they have more sunlight. So they're going to have their summer solstice here. And then quite opposite, when we have our summer, that's when we're going to have their winter down there. So we can see that the northern and southern are going to be opposite. And we understand that because it's that tilt to the Earth that does so. Now we have 2 interesting dates. Those are our equinoxes. Equinox, the equa means equal, and the nox means night. And what that simply means that on March 21st or 22nd, which would be our spring equinox, and on September 23rd, which would be our fall or autumnal equinox, that's where the tilt of the Earth is pointing in such a manner that half the Earth is getting sunlight, half the Earth is getting darkness, and we have 12 hours of each on the equinoxes, and that's why it's called so. So these are 4 of our important dates, and we'll talk about those a lot later on in the course, especially when we get into astronomy real quick. So that's it for this video. As always, good luck on your quiz, and we'll see you in the next video.